Well, hello everyone. It's good to see you guys back on here again today. Now today I want to talk to you guys about air conditioning. You know, I was thinking recently, when it comes to modern air conditioning, whether you want to service a modern air conditioner or whether you want to manufacture a modern air conditioner, there's a lot of technical complication around it. And there's a lot of equipment you have to buy too. You know, you have to have gauges, hoses, vacuum pumps, recovery machines, recovery cylinders. And the reason for all this complication, it comes down to one main reason, and that's because there's a refrigerant that needs to be inside of the air conditioner, and nothing else, nothing but refrigerant and oil needs to be inside the air conditioner. If air gets in or if moisture gets in, it's not going to work right. In fact, it may not even work at all. The other thing is that these refrigerants are not very environmentally friendly, and you know, organizations like the EPA, government agencies, you know, they put restrictions on what you can and can't do with these refrigerants. They don't want you to release them into the atmosphere. You know, if you are going to dispose of an air conditioner or a refrigerator, you know, you've got to prove that you've recovered all of the refrigerant out of it. You have to take it out and prove that you've done this. But what if I told you guys that there's actually a refrigerant out there that doesn't have any EPA regulations around it? Not only that, but there are no international regulations around it. It's completely free. You don't need any kind of license to use it. It's not going to cause any global warming. It's not going to kill the ozone, and it's been around forever. It's called R729. Can you guess what this is? Actually, it's air. Now, that might sound a little bit crazy that you can actually use air as refrigerant, but you can't use it in a vapor compression cycle. But you can use it in something called an air cycle machine, and this is mainly done on, you know, big commercial aircraft. And I prepared a demonstration for you guys today, and I want you to see this. I think it's pretty fascinating. You might like it. So stay right there. Brief explanation. This is a compressor. It's an air compressor. It's not a high pressure air compressor. This is a high volume air compressor. So a lot of air gets sucked up, goes in here, and it gets pressurized to only around 3 psi and comes out this pipe, and it goes into this turbocharger's compressor. Air comes out of this compressor from the turbocharger up in here into this pipe, and this pipe goes into an intercooler. So the compressed air is hot, goes through the intercooler, and it gets cooled off, and then it goes down this pipe here. The cool compressed air goes into the turbocharger's turbine there, and what will happen is when that air expands, it's going to make that turbine spin, and when that turbine spins and expands the air, it's going to get cold. Yes, this is my advanced high-tech oiling system for the turbocharger. Just got a little bottle of oil in there. I know I can hear some of you guys right now saying, oh no, he's going to wreck the turbocharger because that's not the right oiling system. Don't worry about that, it's already junk. I should mention before I begin that this is actually a 3-phase compressor here. I've got the variable frequency drive there to run it, 480 volts, and I got a transformer over here to go from 240 to 480. And so yeah, I mean, they do actually make single-phase ones of these ring blower compressor things, but this is what I could find at the local surplus store. So alright, enough talking. I'm going to turn it on. It's 73 degrees Fahrenheit in the room. I'm going to let you see that thermometer over there. And I've had it down to 55, so let's see what we can do today. so it didn't quite get as cold today as it did in the previous run. Now I'm going to leave you guys with some clips of the previous run so you can see. But the important thing to remember here is that that's just a demonstration that I've made. You know, actual air cycle machines can actually get incredibly cold, much colder than any normal vapor compression cycle can. They're mainly used in airplanes because off of a jet engine there's, you know, a source of compressed air. It's already being generated. The reason that they're not used in like more stationary applications is because even though they do work with just nothing but air and some simple compressors and turbines, they actually aren't really all that energy efficient. There is some hope and some talk of maybe eking out a little bit more efficiency out of them in the future if a better compressor can be developed. But anyways, I think you guys get the point. I think it's pretty cool just using air as a refrigerant, nothing else. But I think that's going to about do it for this one. And yeah, enjoy the next few runs I'm going to leave with you. And until next time, I'll see you guys. And take care.